All right, good morning. So here's the fun part. Apparently we're going to get some snow this afternoon. That'll be exciting. So maybe an inch or two is all that I've seen, but who knows? It's Nebraska. So we have a couple more to look at really quickly, and hopefully we can get this done today a little quick because they are filling up the hallway with boxes here pretty soon. So computers are in, some monitors are in, all kinds of goodies. So I might enlist those of you on campus to help me move those into a spot here until we can start figuring out a plan of attack. So let's take a look at 3-10. And 3-10 says, the credit plan at Tidbit Computer Store specifies a 10% down payment and an annual interest rate of 12%. Monthly payments are 5% of the listed purchase price minus the down payment. So we have some values we need to work with, and it says, write a program that takes the purchase price as input, and the program should display a table with appropriate headers of a payment schedule for the lifetime of the loan. Each row of the table should contain the following items. So the table is going to have the month number, current balance, interest owed, amount of principal owed, the payment for that month, and the balance remaining after payment. All right, so they give us some other information here, and they say, the amount of interest for a month is equal to balance times rate divided by 12. So in other words, 1 month's interest. So it's a simple interest loan. The amount of principal for a month is equal to the monthly payment minus the interest owed. An example of the program output is listed below. So if you've ever bought a car or anything else like that, this is the same kind of thing. So we don't have a set number of months. We just know that originally we started at $200, and we know that in this case, because of the way we've got it set up, it'll take 23 months to pay off this loan. And so it's got some, scroll over. So we have a lot of different columns in here of stuff. Good way we could do that would be to use some tabs when we start trying to format it. But before we get too far along, what we need to do is make some calculations and figure out how we're going to do this. So notice here our payment, the very last payment is also probably not the same because it changes a little bit. So we need to probably put our thinking caps on a little bit for this one. It's not that hard, it's just got a lot of components to that we need to work with. So, all right. So I'm going to make some comments up here, just so I can kind of keep track of myself here. And I actually did the F11, just to give me as much screen as I can here, so that we can see it a little easier, I hope. So the first thing we're going to have to do is, of course, make sure that it's yours. And we need to come up with a couple of things in our brain to kind of cement this. So I could put all the instructions up there, and we're not going to necessarily need to do that, but there are a couple of things that I'm going to think of as, and we know Python doesn't have actual constants, but some things that we might think of as a constant. So I'm going to call one rate, and I'm going to go ahead and just assign it a value. And I know that rate is 12%, but that's not going to work for our purposes. So I need to convert 12% into a decimal number. So 12 divided by 100 is 0.12. Well, it might also be helpful for me to get a monthly rate. And you can use the underscore. I use the underscore in here only because I capitalized it to show me that it's a constant, and we're going to set that equal to, and here's what's kind of handy, is I can actually say rate divided by 12. So whatever that is, so 0.12 divided by 12, that's going to be our monthly rate. And that way, we have that calculated ahead of time, and we don't have to calculate it every time we try to get this value. So, I might also need a couple of other things. So, one of them I'm going to find up here pretty quickly. When I look at all of these items, so down payment, interest rate, monthly payments, blah, 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 blah. So I know that I'm going to need a purchase price or initial purchase price. So I'm just going to call it purchase price, and I'm going to set that equal to 0 to start with. I know I'm going to have some other variables, and this way I can just kind of put in here. That way I kind of create this variable chunk here, and I can see what else we're going to have. So I know that I'm going to have a down payment, and I'm going to set that equal to 0.0. Now, I also know something about that down payment, that it's actually a percentage of this purchase price, but I don't know the purchase price yet. So I have to wait to calculate that. So we have purchase price, down payment, and I'm going to scroll down just a little bit here, and I'm going to take a look at this chart. And I know that I'm going to have several of these then as variables also as I go through here. So I know I'm going to have interest and principal, so I'm going to stuff those back up there as we develop some of these to get there. So I'm going to put a space down, and I'm going to say this is my input price. So I need to figure out what that purchase price is. So purchase price, and notice it pops up for me. That's the other advantage to doing this ahead of time. And I'm going to assign it a value based on an input. So I'm going to input, it doesn't actually show you what they're asking for, but we can come up with something. Please enter the purchase price. Now, I'm going to do one more thing before I forget. I'm going to enclose this in another set of parentheses, and I'm going to go over here and go float. That way that purchase price, I know that that purchase price is in there as a number that I can manipulate. So now that I have the purchase price, I can figure out what my down payment is. And we said that the down payment was that purchase price, or 10% of that, so times, and again, I could try to say 10%, but is that really going to work? We can try it, but I think you're going to be sad. I'm just going to use 0.1. So, I have some decisions to make now. And so, one of the decisions I need to make is, do I just keep the original purchase price, or do I modify it to say that the purchase price now, and I use that purchase price all the way through the program? Well, I'm going to make a decision right now, because I think at some point I may want to reference that original purchase price. And so I'm going to also assign a new variable. And that new variable is, I'm going to call it financed amount. And I'm going to set that equal to purchase price minus down payment. Now, I don't have to do it this way. I could probably keep that amount, but I think that's kind of a nice way to do it. And so now I'm going to go back up here just so I can complete this. So, I still haven't done really anything, but I want to kind of keep this. I like having the variables up here just so I have a running list of them, and it makes my life easier when I'm trying to figure out what's going on. And we can certainly see financed amount is the purchase price minus the down payment. Perfect. Well, I also run in this, so I can make it as visible as possible here. So our payment we calculated somewhere up here, the monthly payments are 5% of the listed purchase price minus the down payment. So monthly payments are 5% of the listed purchase price minus the down payment, or that amount financed. So I need to figure out what my monthly payment is going to be. So I could just say monthly. Now, this is subject to change at that last month because only the rest of the months are is it going to be the same. So I'm going to save it up here also, monthly payment. And I'm going to set it equal to 0.0. And again, Python is really okay with me not doing any of these. This is really a how do I keep track of what I'm doing a little easier. So we know that the monthly payment then is equal to our purchase price times, so this would help if I actually typed it instead of just said it. So our purchase price minus the down payment times 0.05. Well, I already have calculated part of that. So instead of monthly payment being based on the purchase price, it's based on that financed amount times 0.05. I also need, as I scroll down through here, I'm keeping a running balance. So, ending balance in here, starting balance, ending balance. So, I know I probably need to have a number that says, this is what the total balance is. And I'm going to say then, I'm just going to use the word balance. So I have another variable I can use. And I want that on the financed amount. Again, I might want to come up here and I might want to put in balance equals 0.0. And again, it cleans house and it puts them all in this for me so I can see what we're doing. So I think I'm ready to start doing some calculations. So input price. So I'm going to come down a couple lines just to make this maybe a little easier to see. And I need to come in and create my header. So my header like this. Well, I'm going to cheat just a little bit because they've worked on some of the spacing, and we may need to do some modification, but print. And I'm going to come over here. I'm going to make this big enough to see, and I'm just going to grab that line. And why I'm doing that, notice these are kind of centered on top of the tabs. Well, that's what we're going to do. This is my tab indentation, but I'm going to try to center it as close to that as possible. So I'm just going to put that into a print statement for myself. Makes life kind of easy if they did that for me. And we'll see if we get really close to where those elements are. So now we have to do a little more calculation. All right. Here's where it gets ugly. We need to figure out how we're going to create these values But more importantly, how do I continue to create them over and over and over again? So I'm fairly certain we're going to have to use some form of a loop. But what kind of a loop do we want to use? Do we know how many times it's going to run? Now, we could probably calculate how many cycles, but maybe what we want to use is my friend a while loop. And so I might start with a while loop. So while, now we need a condition. And the condition I'm going to think of is this balance up here. So we originally started with the balance as being the financed amount. That's how much you still owed. As this loop goes through here, we're taking off a chunk of that balance every single time we run a loop. So hopefully then we could say something like while balance is greater than 0. So in other words, I haven't yet paid off my loan, so now I could start a loop to help me a little bit. All right. Couple of things we need to think about. And the first one we're going to do, we haven't done a ton with if-then statements, but when I think about this, one of the conditions that I run into really quickly is at the end, my balance and the amount of my monthly payment are different. So the last payment typically on a loan is different than it is the rest of the month. So I think the first thing I'm going to do is I'm going to say something like if monthly payment is greater than the balance, help if I spell. So if monthly payment greater than balance, so now I've actually created a second indent there. I'm just going to say then my monthly payment becomes the balance. So, does that make sense? So I come in here, and that last month, my payment, well, normally it's $9, but we only owe $3.80. So that's going to make our payment then $3.80. So the other thing I notice here, because we're paying interest ahead of time in this loan, is notice here it says my interest is 0. So the other piece I might put in there, just to make it explicitly clear, is I'm going to then add a value called interest. And I'm going to say that's equal to 0. Now, I don't have interest up here, so I probably should put it up here. And we're going to see a lot of those as we go through here. Interest equals 0.0, so down here it's going to have a value. All right, so this is going to say if we've paid off the loan, that last payment we wipe out. That's the whole purpose of this if statement here. So I go down a line and it stays at that indent. So I can do a backspace to the different levels, or I can do a tab to the different levels, or shift tab will go backwards. So be careful of these levels in there. So I'm going to do something else here. And in fact, I'm going to use our else statement. Because if monthly payment here, if that's not true, then we know that the monthly payment is higher than our balance, right? So, or lower than our balance. So we have something to pay off. So we can use this else statement, and we can calculate then what our interest is each time. So we could say interest equals our balance times, and all the way up top we did this one called monthly rate, and we could do that monthly rate. So now we know how much interest each month we're going to generate. So we've got a couple pieces of it there. So how much we're going to pay on principal So in other words, how much we actually pay to lower that balance may be the next thing we need to calculate. So principal is going to be equal to that monthly payment minus interest. So in other words, my monthly payment here was $9, but I'm paying $1.70 or $1.80 in interest. When I subtract those, that means I'm only paying $7.20 towards that amount. If you've had a home loan, you'll see something very similar, and you'll say, my goodness, the first couple of years, I paid very little on principal. It's almost all of interest. Okay, so principal, we can calculate that. So as we come through here, we also may need kind of a holding place for balance. And here's the reason why. This sheet says we need a starting balance and an ending balance, right? So I need to figure out what that ending balance is going to be. So it's going to be kind of a temporary piece. So I could call it whatever I wanted to. Maybe, well, we could even call it end balance. And so that's going to be that balance minus principal. All right. So we figured out what the principal is. We figured out, so this is kind of our temporary holding spot. Once we figure out how to print all this, once we figure out how to print all that out, then what I'm going to do is I'm just going to swap that. So I'm going to then say balance equals end balance for the next cycle through. Remember, this is all in a big iterative loop, and right here is my print statement that I've got to come up with. The last step in here, so while this is less than 0, notice I also have another value in here that tells me, it says what month it is. So I probably need to come back in here and have a month in here also. And I'm going to set that equal to 1. Just because I don't want to have to count month. God, I can't speak there. 0. So at the end of this, not only is my balance going to flip to the new lower balance, but I'm going to say something like this: month equals month plus 1. So I can keep track of those running months. Okay. First thing I'm going to do through here is, I haven't got my print statement set up yet, but we'll work on that here. Maybe I'll do a print statement real quick. All right, so print, and what it's going to print out, I know I've got to have month, and my starting balance over here. So somewhere over here I've got a starting balance. So I think I can use balance because I haven't changed it yet. I know I need the interest. I got to figure out what else is in there in this order. Okay, interest, principal, payment. So principal, my monthly payment. Monthly payment, and then that ending balance, right? Okay. And so I'm going to have ending, what do we call it? Ending or end balance. All right. So I've got hopefully most of the math. Let's go run it, and let's just see how badly I've managed to mistype while I've tried to talk, because that's always entertaining, at least to me. All right, I'm going to hit run. Line 23. Oh, hang on. While balance, I was talking and not typing at the same time. So while balance is greater than 0, so now we'll try. Okay, so please enter the purchase price. And the first thing I see is I didn't leave enough space, but let's just say, let's put in the 200 like they did in their example. Oh, what is this? Let me scroll over. So starting balance, interest to pay. Let me run it again so we can reformat it. So 200. Oh, well, I have some numbers. I have starting balance of 180. And I think most of that looks right if I look at the numbers, except look at all the values that seem really, really odd. And why they're odd is we're multiplying these by percentages, so we have, a huge value, and we're talking about dollars. So we need to come up with a way to make this a little more palatable to what we're going to see. So we need to think about formatting. And there's lots and lots and lots of different ways we can format. So I think I'm going to, let me make sure I save this. I want to delete it. I'm actually going to download it real quick just so I have it. Keep. Alright. So I need to figure out a way that I can format these. And I want to format them fairly precisely. So I know that each one of those numbers I want to 2 decimal places, right? Because they're a number. So is there a way that I can do this and make life easy? So first thing I'm going to do, I'm going to find me a blank shell here. I'm going to come over here and I want to format numbers to 2 decimal places in Python. Google's so smart, it's like I search on that a lot. So let's see. How to print 2 decimal places. So, oh, what is this? The string format as a string and float as a number. Alright, let's see if this makes any sense. So, here we have a number called float, and we want to format that, and it will appear as 2.15. Well, so here's what we're doing in this particular example. Is this the only way to do it? No. So let's take a look and see if other ways there are to do it. So, accept all cookies. I'd like to display decimal with 2 decimals. So, they're doing one from a math format. So we can do a lot of different ways we can format it. So here in our line here, these are kind of string formatting shortcuts. And so if I look at those, let's see. I'm going to take something, I'm going to have 2, and it's going to be a float. So there are lots of ways to do this. There is the round function, so we could round things at 2 decimals. What we traditionally did, before we had some of these fun things, is this is really crazy, but let me show you an example of what I would actually do. One of the functions I know I can do is I can actually truncate it as an integer, right? So we would then multiply by 100 to get 2 extra decimal places, truncate it or round it, and then take those 2 decimal places back so it would be essentially at the right area. We have some easier ways we can do it now. So our book talks a lot about it. I'm going to give you a little bit of a hint of a way we can do that. So I have my set of print statements here. Let me see if I can make that as big as possible. So we know we're going to print all those items. Now, I could have went out and we could have rounded them. We could have done all kinds of things. I don't want the values themselves, though, to change. Because as I'm calculating these out, I want to have a lot of decimal places behind the scene. When I print it, though, I want it to be set at a specific format. Does that make sense? So, I need to figure out a way that we can format these and we can also then, now the weird thing is these format commands live inside of our print statement. Okay, so I'm going to actually add another parenthesis in there. Alright, so if it were not in a quote string, I would think that this is actually doing a math operation, but it's really doing a formatting operation. And remember, that's this modulus operator if we're doing a math operation. Oh, it turned red. Okay, why did that turn red? So, I'm going to also specify how long that item is. Alright, so I'm going to call it 15 units. Then I'm going to put a period in to specify I'm moving to the next one. So, put my modulus operator. And I'm going to say it also is 15. And I'm going to start another one. To float. So I want it to be 2 decimals in float. And it also then is 15 characters long. So, does that seem like it makes some sense? I notice it even lights them up in red for me here. That makes it kind of nice. So, I've got 1, 2, 3, 4, 5, 6 elements in here. So, I'm going to go through and do the similar thing then for all 6 elements in there. Now, if I just end it, I don't know, this might not be a good idea, but I've never tried to just do part of it, but let's see what happens. I didn't like the string literal because it didn't know the string. Okay, so I have to put in the rest of them. So hang on a second. Because I didn't know how to deal with just part of those. Alright, so I think I can do floats for the rest of that, so I'm going to do this. Think that'll work? I got the right number in there? Oh, hang on. Put a chunk. Alright. So, notice I had to put in the quote string in there because we're all doing that only as a quote string. Alright. Let's see if it likes that any better. String object not called, just a comma, probably. Let me see what happens when I run it. purchase price of 200, if it'll let me. It's not going to like that. All right, string object is not callable. Okay, I'll have to go figure out what I've done weird here. Why does it not like one of my strings? Let me see. I probably typed something really silly in here. Oh, I forgot a piece. Trunk. Alright, so true 100. Incomplete format. So I missed somewhere in there one of my format pieces. Alright. I'm going to have to go through, because when I type and I talk at the same time, you never know what's going to happen. So let me pull this. So my example, I just used 17 instead of 15. It doesn't make much difference. It just fit the number of letters a little closer. So now let me run this. And then it produces a result very similar to our example. All right, so let me show that to you again here. Well, we're not limited to, so we're just trying to look at that. So 2 float, 2 float, 2 float, 2 float, 2 float. Yeah, there you go. All right, so I'll leave that up for a few seconds while I talk about it here. So that's one way we can format that. There are a lot of others. So I could actually use my tabs and go across and do it the same way. This is just kind of handy because it not only can I format a space for it, but I can actually format then a how many decimal points it has. So it kind of serves a twofold purpose really quickly. It's kind of ugly, but it serves its purpose there. So, all right. I'm going to run this one more time. We aren't limited to that $200. So maybe you're going to go buy a new car at $25,000. Now, it's not going to fit very easily because, let's try it again. All right. So I had to have enough space to make that work. So in that case, in the same model, doing 5% down, or 5% every month, my monthly payment, $1,125, and it shows my ending balance as we go down. Now, what you'll notice is because these values are bigger, now this is off up here. And so I probably need to come up with a little better way to format these across. So, but you can take this basic program now, and you could modify it to do a lot of other things. So, up here where we have a rate, you could actually take that in as an input. So you could actually ask, hey, what interest rate are you paying? So you could go into a car dealer and say, hey, I'm paying, 13% interest or 5% or 4%. So once you have some basic structure, you can start to do a lot of things with this basic code. So this just simply lets you do it. The formatting, until we introduce some other elements, that formatting here is where it gets a little ugly. There are 100 different ways to do this. So you don't have to do it this way. And certainly, I would probably reformat my start line up there, or my header, a little differently. So if I had used tabs, there's some advantage to using tabs, to formatting each one of those and then using tabs also. Just just different ways we can display that output. And it weirdly doesn't show very well on here. So let's do the simple test and see if the numbers look right. And I think it's going to plug in some numbers that are going to be very similar to us. So here they look for the table's not hard-coded in there. People will do that. And so, yay, it produced the right output, and it doesn't look for, because it doesn't have a way to not look for it. Tests for 200, which we know, and it does a $425.95. So that's one of 150,000 ways to do this. As I'm looking at it, I might think, you know, a for loop might be a better way to do that, because I could still base that for loop. I could calculate how many payments we had ahead of time, or I could actually do a for loop in a very similar fashion. I might want to format it differently. There's lots of different ways we could change this. So try new things. Try things. That's the only way we're going to learn how to get some of this a little quicker. All right. Oops. So the last one is actually not for credit. If you've logged into it, you'll say, "Oh, I don't have to do this one for credit." But I wanted you to try something a little more challenging. And I thought this was kind of an interesting model. I kind of like this problem simply because if you've ever been to a casino, you know that there's a point where it's not going to get any better. And we probably need to, no, update whatever that was. All right. So this program takes some of the things we've already done. So the player rolls a pair of dice. If the dots add up to 7, the player wins $4. Otherwise, the player loses $1. Supposed to entice the gullible, a casino tells the players there are lots of ways to win. 1 and 6, 1 and 6, 2 and 5, and so on. So if we've had statistics and you start looking at math, yeah, there's some multiple ways to win, but there's a lot more ways to lose. So program should take as input the amount of money the player wants to put into the pot, and using a random number generator, play the game until the pot is empty. At that point, the program needs to print the number of rolls it took to break the player, the maximum amount of money in the pot. So how many dollars do you have? 50. You're broke after 220 rolls. You should have quit after 6 rolls when you had $59. So not only does it tell you you're broke, it tells you when you should have quit, and you would have walked away with additional revenue. All right, so let's think about this a little bit. We need to roll 2 dice, which we've actually done previously, and then we need to see if they add together to 7, in which case our balance is going to go up $4. Let me scroll up. Otherwise, we're going to lose $1 every time. All right. So, first thing we're going to do is we need to find a way to get some input from our user. Well, actually, first we're going to put an import random in there, because we can't use those random codes unless we import that random library. So, we need to get, so I'm just going to call this balance. And we're going to get that from our user. And just to make life easier, we're going to say you're going to only put in dollars, because we can't lose a partial dollar, we can't win a partial dollar. So if we do those as integers, it makes our life a little easier. Input. Please enter how much you want to lose. have an extra. Yeah. All right. Trying to make this big enough so I can use it. All right. So I'm also going to come in here and I'm going to convert that to an integer right away so I don't have a problem later on. So that's one value I'm going to have. So I know I'm going to have the value balance. You could call it something else if you wanted to. I know that I'm also going to have some other values in here. And in this case, I might just add them here. So max balance, or whatever, you could just call it max if you wanted to, is equal to the balance original. So when the program first starts, the most money you have is also your amount you've had there. We also need to keep track of how many rolls when we have that max balance. So we could call that roll count max. We could call it about anything, but we just need to document it and make sure what it is. And because we haven't rolled yet, we're going to say that's equal to 0. We also need a count, because we're going to keep that count all the way through there until you lose, so we also need a second value for count, and we're going to set that also equal to 0. So now we need to make a loop. So our loop is pretty simple. As long as we still have money, so as long as this balance is greater than 0, so while balance greater than 0, we're going to do a loop, right? We're going to continue to spend money. At the very beginning of this, I might want to put somewhere in here count equals count plus 1. So I can keep track of how many times this loop goes through. And then from a previous assignment where we did the die, so we can simply say die1 equals random dot, and it will actually, well, maybe one in there. Because the easiest way, instead of doing rand range, is probably the rand integer. Because we know we want it in a value between 1 and 6. Unless you're throwing some different dice. So, here's what I'm going to do to copy that. Copy. Paste. And now I'm going to change that to die 2. So, I have 1 dice, I have 2 dice. I've figured out a way to spin the dice. Now I just need to figure out, did I win? So, the only way in here we said that you win is what? If those two numbers added together equal 7, right? So if die 1 plus die 2 is equal to 7, then our, what did we call it, balance equals balance plus $4, right? Otherwise, else, our balance, instead of retyping, I'm going to do this, and I'm going to change that to -1. So our balance is going to go down. So our program now is actually going to run our balances. What we don't have is a way to keep track of where our maximum value is. So here's what we're going to do. If our balance is greater than, and we called it max balance. So if that condition is true, I simply swap them essentially. So I move that value from max balance. So max balance now becomes balance. Whatever that value was in balance shoves it over. The other piece I can do then, because I'm counting up here, is I can say, all right, so this count then becomes my, what did we call it? Roll count max is equal to count. And so that will tell us then that this is where we had the maximum number of dollars. And so each time that changes, that should go up, we hope. So that's our loop. Our loop really isn't that horrible. We know that our count's going to change. Our balance is going to fluctuate, so there's a way out of this loop eventually. And so then we need to come up with a print statement that outputs all this data for us. So let's see what they look like. How many dollars do you want to do? So we just need to come up with a way to say print you are broke after and that would be that roll count max rolls, and then we can come up with a print for you should have quit when, no, you should have quit after, and then that's that roll count max, comma, when you had, and then we can put in our number of dollars, whatever that was. Let me move this over so you can see it a little better. When you had and that's our max balance. So, see what horrible typing error I made in there. Alright, so in theory this will work. Again, we'll run it and we'll see what kind of error we have. Unexpected indent in line 22. Alright, come back over here. Oh, hang on. There's something weird going on there. Alright, I apparently put an extra one in. Let's move that back over. So, again, I didn't format it very nicely, and in fact, right here will drive me crazy. So if I said I have $200, you are broke after 310 rolls. You should have quit after 310 when you had $240. Okay. That doesn't seem to work very well, so I might need to come back over here and see what I've done wrong. You should have quit after 310 when you had. So, why does my roll count max, why is it always taking in that? So I may need to think about why that is. So, roll count max starts at 0. So, if I'm not sure what's going on, sometimes I will put in these print statements to kind of let me know what's going on with this particular program. So, in this case, trying to think where I might want to put in a print statement. Because the balance one seems to work, so why does the roll count max come up with that value? So, I want to maybe print this every time. So print roll count max. Come back here, and I'm going to run it again. And I'm going to do a smaller amount because it's going to generate a lot of. You're broke after 0 rolls. You should have quit after 0 when you had $20. Alright, so I seem to have some structural problem going on here. So I need to analyze and figure out what's going on and why it's not working the way I think it is. So count equals count plus 1. That doesn't look like it could be wrong. Because then we know that every time this loop runs, it's going to increase that. So die 1, die 2. Well, if I want to make sure, I can print die 1, die 2, and I'm going to go take my other print statement out just for now. And now if I run it, let's see if we can come up with an error. Alright. So, it looks like I'm getting values in here. So, that part works. So, I'm going to come back up, take a look at my code. So, this seems to work. Well, that seems to work. Alright. So, by printing that worked. So, I'm also going to print count. So, now I'm going to run it again. And this is just kind of that, we have to formulate how we're going to create a fix of this. So, my count said 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait a minute here. So, that seems a little weird. So, count. Let me make this as big as we can here. So, my count seems to work. Something else seems to be off in my coding here. So, we know that this loop is based around the value of balance. So, balance equals balance plus 4, based on if it's equal to 7. So if it runs through one time, and we get a 7, that count should be 1. So I don't need that line in there. Otherwise, the balance equals balance plus 4. So we're either taking away or adding 1 to our value. Well, that doesn't look wrong. So if my balance is greater than the value for max balance, which we set up here at the original value for balance, then max balance equals balance and roll count max equals count. But something weird is going on here. So we're running more times than what we should be able to. Can't do that over anymore. So I maybe need to put some other print statements in here so I can see what's going on right now. So first thing I'm going to do, now I'm going to print balance. And so when I print balance, let's see what happens when I run that. $10. You're broke after 21 rolls. Okay. Well, that makes a little more sense. So here's our balance. So we lost $1, lost $1, lost $1. We gained 4, lost, 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 gained. And so you could scroll through and you could see how that went. So this said, you're broke after 21 rolls. All right, that part seems to be functioning. You should have quit after 21 when you had $19. But I don't think at 19 or 21 is when I had $19. So if I look, that really should be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I lost track because I can't see that high. So it doesn't look like that is, there's something going on that's incorrect. So I need to figure out what and why it's doing that. Because it says I died or I ran out of money at the same point that my count is. So you are broke after X number of rolls. So that right there, that's not my max count. My max count is here. So let's try that one more time. So I'm going to hit run. And I want to lose $200. You are broke after 1,595 rolls, and you should have quit after 56 rolls when you had $214. So, I'm going to go back in and fix that just slightly. Take out my print statement for balance. So, run it one more time. So in this particular game, I lose. I never get a huge advantage, though. Even though we say, hey, you get $4 every time it's a 7, but any other combination, you lose $1. Well, if we look at the math behind it, how many different combinations can we have that are 7 versus how many possible combinations there are? So, there's 6 sides to every dice. So 6 times 6 means there's 36 possible combinations. How many combinations, though, can get to 7? So a 1 and a 7, a 7 and a 1, flipping the dice around, a 3 and a 4, 4 and a 3, 5 and a 2, 2 and a 5. So there's only 6 combinations that would win us. So when we run this, so in this case it did take 10,000 rolls, but I should have quit very early on. So it shows that once I reached a very small portion of that. And if I do that again, so when we run repeated tasks of the same thing, we call it a Monte Carlo simulation. So what it's telling me is I should have quit in most cases very, very early on, or I'm going to lose my money. So 200 rolls, or $200, you should have quit after 35 rolls when you had $210. So it's just kind of an interesting way to do this. We can change the logic behind it if you want to. So you could actually add a second winning combination. So if die 1 plus die 2 equals 7, or die 1 plus die 2 equals 11, that's going to change those odds just a little bit. So now it's kind of like rolling a 7 or 11 on the first roll. So 200. I may have done something wrong, apparently. It may not like that I didn't. So now I've added an OR condition. It should work, but I managed to probably fumble up some other code in there when I did that. So what this would do is pay me then if $4 if I got an 11 also. So different ways we can run around here. When I'm moving these windows around, I tend to grab and monitor or mangle some of the code. So just some other things we could do and play with if you want to do this. So the other things you could do, you could make up a set of other rules. So if I wanted to, and you wanted different rules, so if it's equal to 7, else, well, there's another one we can use. So there's something called an elif, and then we could say die 1 plus die 2 is equal to 7. And you could do a whole list of those. Then you could say balance equals balance. Maybe forgetting, let's see, not a 7. We want to do something different. So 6, 2 equal signs. So if die 1 and die 2 equals 6, balance plus $2 or something. So you could add some other ones in there. You can do a whole list of those L-ifs if you wanted to make this gambling a little more interesting. So, just some other things you can do to entertain yourself when you're playing with these. So, you can do an if, then else. You can do the L-ifs to add additional conditions in there. So, just kind of something to look at and try and see. All right. So, for this week, there are some programming assignments. Next week, we are going to introduce a couple of new items, and then we take a week off for spring break. Everybody clap. So hopefully everybody's doing something fun for spring break. All right. Let me pause this and